Hi folks, Matt McSpirit here, Program Manager at Microsoft, working with our customers and partners around the new Azure Kubernetes service on Azure Stack HCI. And in this session, I'm going to take you through everything you need to know to get started with AKS on Azure Stack HCI. Now, before we get into AKS on Azure Stack HCI specifically, it's important to take a step back and understand Microsoft's strategy in the hybrid space. Now, the beauty of this strategy is it really meets you where you are. So if you've got a desire to be 100% in the cloud, Azure is a fantastic platform to support that. However, for many organizations, workloads running on premises is a reality today, and it will likely be a reality long into the future. It might be for networking reasons, things like latency to the cloud or a completely disconnected environment. It could be compliance and regulations. There are a number of valid reasons for keeping some workloads on-prem. Now that's where this hybrid strategy comes into play. With Microsoft's hybrid approach, we're bringing specific Azure technologies from Azure down into your on-premises environments, and at the same time enabling centralized management, control and governance for those on-prem environments, all from Azure. Now when it comes to IoT, Microsoft provides a suite of powerful IoT solutions to connect and manage your IoT devices at the edge, all managed centrally from Azure. When it comes to modernizing your data center and edge sites, the Azure Stack portfolio provides a comprehensive set of options for delivering modern infrastructure for your traditional and cloud-native workloads. Now that family includes Azure Stack Edge, Azure Stack HCI, which we'll discuss a bit later, and Azure Stack Hub. And all these options provide powerful on-prem capabilities to run your key workloads. Finally, we realize that while many organizations have on-prem resources, they also have a multi-cloud strategy, yet still desire consistency. And Microsoft's working to bring select Azure services to run outside of Azure on any infrastructure, yet continue to manage these services from one centralized location, Azure, through Azure Arc, which again, we'll explore more later. Now, unless you've been hiding under a rock, you've likely heard of Kubernetes, but for those of you that haven't, what is it? Well, as app development moves towards a container-based approach, the need to orchestrate and manage resources is important. And Kubernetes is an incredible platform to provide the ability for reliable scheduling of fault-tolerant application workloads. Now, AKS in Azure is a managed Kubernetes offering that further simplifies container-based app deployment and management and has a load of key benefits. As a managed service, not only do you benefit from the simplicity, but you also benefit from all the learnings of Microsoft engineers building AKS, thousands of engagements with enterprise organizations, and deep integration with the open source community. And all of this comes through in the form of comprehensive best practices and recommendations for running AKS-based applications and services. Security is part of AKS by design with multiple layers of hardening and isolation, and in addition we've published a security baseline for AKS, which contains recommendations that will help you improve the security posture of your deployment. And it's fully supported by Microsoft, and that's made up of certified Kubernetes experts who can help diagnose and troubleshoot any issues you might run into. And finally, you can manage your AKS resources side by side with non-Azure based Kubernetes resources, all from the Azure portal, enabling you to manage applications consistently, apply governance and policy, and more. Now this brings us nicely onto AKS for Azure Stack HCI, again with 4 key pillars that we'll explore through the rest of the session. Naturally, the solution has been designed with consistency and hybrid front and center for workloads running on both Linux and Windows platforms, all with the highest levels of ingrained security. So let's dive into these one by one and look at some of this in action. So firstly, AKS on Azure Stack HCI brings everything you need to start running your containerized workloads in an easy to deploy solution. It takes the best of the proven open source software of Kubernetes and adds in Microsoft enhancements for running on Azure Stack HCI. Now, for those of you out there who've ever tried to deploy a raw Kubernetes infrastructure, it's tough. And that's where one of the key benefits of AKS HCI comes in, as we'll see in a minute. 2 simple, quick and easy deployment options with PowerShell or the Windows Admin Center, meaning familiarity and ease of use are both top of mind here, building on the existing IT pro skills that you have. But what's actually going to get deployed? Well, architecturally at a high level, at the base, you've got Azure Stack HCI running on the metal. And on top of that, in virtual machines, AKS HCI deploys container hosts, both Windows and Linux, which will ultimately run your workloads. Now, in the case of Linux, this is Microsoft's Mariner OS, and these are updated directly from Azure, but obviously you control when you apply those. In addition, Microsoft's built the integration for Kubernetes to work effectively with the underlying compute, storage, networking, and clustered infrastructure in Azure Stack HCI. And combine this with the Kubernetes open source software, and that, bottom to top, is the AKS HCI solution. Then on top, you can run your Kubernetes applications. optionally managed from Azure Arc. Now, to dig one layer deeper, when you deploy AKS HCI, there are actually two major steps. The first on the left here is to deploy the platform services, also known as the management cluster. And this deploys a couple of VMs, or just one in preview, that essentially orchestrates and controls deployment and management of the target clusters, here on the right. And this is where you run your applications and workloads. Now, when you deploy Kubernetes target clusters, AKS HCI automatically deploys a set of VMs to act as the control plane for the target cluster, including at least one load balancer. So that's everything that gets deployed. But what are your actual options for deployment? Well, you've actually got a couple of options for running AKS on Azure Stack HCI in production, and then an additional option if you've got limited hardware and just want to evaluate AKS on Azure Stack HCI. So on the left, we've got our primary deployment option. For production environments, that's running the new Azure Stack HCI 20H2 operating system on the Metal. And if you're not familiar, Azure Stack HCI 20H2 is a hyper-converged infrastructure cluster solution that hosts both traditional virtualized Windows and Linux workloads in a hybrid on-prem environment, and is the future of infrastructure investments in compute, storage, and networking on-prem. Plus, it's also available as a subscription, so it fits with your cloud billing approach. And Azure Stack HCI is also a great place to run AKS HCI, and that combination is our primary option for a bottom-to-top supported configuration in production. But what if you've got existing hardware on-prem, perhaps with SAN storage? Well, Azure Stack HCI 20H2 is hyper-converged, so it won't work with SAN storage. But if you prefer, you can run a Windows Server 2019 Hyper-V based physical cluster and run AKS HCI on top. Now, if you don't have much spare hardware, maybe you just have a single physical node, and if that's the case, for eval purposes, you can also run AKS HCI on top of a single Windows Server 2019 Hyper-V host. Better still, if you don't have any hardware at all, but you've got an Azure subscription, you can even evaluate AKS HCI nested in a single Azure VM, and that's what we'll show you next. Now, AKS HCI is currently in preview. So in order to access the bits, you've got to fill out this registration form, and the links will be in the resources a bit later on. And once completed, you'll have access to those bits to run on a system or systems that you've got available. Now, if you've got some spare physical hardware that you can install Azure Stack HCI 20H2 or Windows Server 2019 Hyper-V, you're great. Install, cluster, and run AKS HCI on top. But if you haven't got access to any existing hardware, or maybe you've only got a single node, you can still evaluate AKS on Azure Stack HCI. It'll install on a single Windows Server 2019 Hyper-V host. But if you've got no hardware at all, what I'm going to show you now is essentially our evaluation guide, which actually walks you through essentially deploying an Azure VM to act as your host to run AKS HCI. So it enables you to evaluate functionality, key features, and experience what AKS HCI has to offer without actually needing any hardware on premises, which I think you'll find is pretty cool. And as you can see from the guide, what it shows and what it details is all of the things that are going to get enabled. It shows the architecture, it shows a little bit of information about nested virtualization as well. And if we continue to scroll down, you'll see that the workflow, the approach of deployment, you deploy your VM in Azure in part one, and then you take a path of either with PowerShell or Windows Admin Center to deploy AKS HCI. And if we drill into another one of those pages, specifically now deploying the Azure VM, you'll see the kind of things that get deployed. So the Azure VM running Windows Server 2019, Hyper-V, DNS, DHCP, all of the necessary stuff. And then on top of that, you can then walk through the simple deployment of AKS HCI. Now, in addition, the guide focuses on helping you understand key thought processes around what VM size you would choose in Azure, because it needs to be big enough to be able to run multiple nested virtual machines for AKS HCI. So there's a consideration there. You can't just deploy on a really small VM. That's not going to work. So there's considerations about size and storage and cost as well. So we provide some useful information on that as well. And then when you get to the specific deployment detail, you can see what we're actually going to deploy. As I said before, Windows Server 2019, the Hyper-V role, DNS, DHCP, all of that is going to be configured for you. And Windows Admin Center will be pre-installed, and the Microsoft Edge browser, all of that will be handled as part of the Azure VM deployment process, of which really all you need to do if you're an ARM template person, if you're a GUI person, click on the Deploy to Azure button. It will take you to the Azure portal. It will prompt you to complete this form, which essentially is pretty much pre-completed for you. You only really need to add a few extra fields or resource groups, some credentials, Everything else you can pretty much leave comfortably at the default settings. I would recommend enabling the auto shutdown and specifying a time though, because that can help you to control costs. But once you've specified all of those characteristics and parameters, all you need to do then is click create, and within about 15 minutes, maybe slightly longer, you'll have a VM that's all ready to go and pre-configured. Now, if you prefer to deploy with PowerShell, you've got that option as well. So rather than go to the portal and the template, you can use the PowerShell script that's here as well. So definitely check that out. It's definitely worthwhile, and it will walk you through all of the key steps of deploying not only the Azure VM, but then onwards from there to deploy AKS HCI in that environment. And that's what we're going to focus on for the rest of this conversation. So let's minimize this and let's dive right in to actually start to deploy AKS HCI in this environment. Now, in my case, I've already registered, I've downloaded the bits, I've imported the PowerShell modules into my environment. And all of that is really easy, it's quick, it takes a few minutes, and it's documented in both the eval guide that I just showed you and also in our official documentation. So what's the first thing that I'm going to run? Well, actually on the right here, I've got my PowerShell ISE. So that's where I'm going to step through some of the key commands here to actually deploy AKS HCI, at least initially the platform services, the management cluster. And remember, there are two stages we talked about. There's the platform services and management cluster, and then there's the target clusters where you will run your workload or workloads. So in this case, we're going to focus initially on that platform services. And on the left, I've got Hyper-V Manager. It's a little bit small, but what you'll see there is as the process continues, you'll see throughout this whole process, VMs will start to be deployed as commands are executed and processes are completed. In this first one, you'll just see a single VM be created. So what we're going to do first is just run this get command so you can see some of the stuff that's actually been installed as part of the module installation for the PowerShell modules, and you'll see a various number of different functions there. And then we run this initialize AKS HCI node, which is going to check you've got the relevant roles and features and settings configured on your host or cluster, if it was a clustered environment. In this case, everything's already good to go. We've got all those roles and features ready, and WinRM is configured correctly. Now, the next setting is really about choosing your networking environment. Now, if you're running DHCP in your environment, you would use the first command that I'll show you. And if you're running a static IP environment, which many of you are, then you'd use the settings shown on line 9 through 13. We just need to specify a few extra settings. Basically, you're defining a network object in this first section here, where we're defining the VIP pool start, so the networking pool, a range of IPs where they'll be used by the AKS solution to deploy and provide IP addresses to workloads and other elements of the infrastructure. Then if you choose the static IP approach instead, you'll see you've got to provide a little bit of extra information: gateway, DNS servers, IP prefix, and then you've also got some additional ranges required, or one specifically for the Kubernetes node IP pool, start and end. So these are something that you would work with your networking team on if this was in a production environment. In our Azure VM, for the evaluation purposes, you'll see we can use either DHCP or static. In this case, I'm just going to use DHCP. So we'll kick that off. We'll run that command. And then we'll run the set AKS HCI config. And what that's going to do is essentially take that network object we just created. It's going to also ask for some additional parameters, optional parameters in many cases, such as where you'd like to store your images, where you'd like to store your config files. But then in addition, there's some other parameters where you can start to specify sizes and other characteristics, and you should refer to our documentation to check out all of those in particular. But when you run that, you're essentially telling the AKS HCI system, this is what my configuration should look like. These are some of the characteristics. So we're not installing AKS HCI at this point, we're just defining almost like a template for deployment of AKS HCI. So once that's done, it takes just a few seconds. Then we go ahead and we run the installation. So it's just the install AKS HCI, which takes that config file. You don't need to pass a path for that. It already knows where to look. So it takes that config file and then it starts applying the config. And we've accelerated this as for demonstration purposes a little bit. So it's going a lot faster than it would normally. But the actual steps now is it's taking that config, it's downloading the Linux Mariner OS image, it's extracting that. Then it's going to start actually building a VM based on that image, and you'll see it's appeared on the left in Hyper-V Manager. It might be a little bit small, but you can make out that there's now a VM running in there with, in this case, 8 gig of RAM. It's starting up, it's getting the services ready. And this is essentially going to be our our control plane VM infrastructure for our platform services, the first step that we described as part of the deployment earlier. So that just takes a few minutes, and that is now available. And if we get the AKS-HCI cluster with this PowerShell command, you'll see single control plane node, there's the latest version and the name of that object as well. And if we want our kubeconfig file to be able to access this through something like kubecontrol, that's how we run that. We use the get AKS-HCI credential, pass the name of the cluster, and I've just printed out the folder and the location where that config file will be stored. So with PowerShell done, let's flip over and show the equivalent process deploying the platform services, the management cluster, using Windows Admin Center instead. So same registration process, download the bits, but as you can see on the screen here, on a different system, I've got Windows Admin Center open. I've already imported the AKS for HCI extension, so our documentation walks you through that, as does the eval guide, so it's really straightforward. But what we're going to do first is we're going to drill into our particular VM host, our Azure VM, running Windows Server 2019 Hyper-V in this case. Remember using nested virtualization. You'll see I've got my extension at the bottom here, Azure Kubernetes Service. And all I need to click to deploy or start the deployment of the platform services is click Setup and then follow the steps. Now we meet all the prereqs in our environment, so we're just going to provide some credentials for the host operating system where we're going to deploy AKS-HCI, and it's going to check that Admin Center is connected to Azure. That's one of the prereqs. And it's going to provide some information on some of the changes to be made. In this case, some of the firewall changes are going to be implemented, some of the roles and features enabled. Then we choose our management cluster name and where we're going to store our VMs. We choose DHCP or static IP, similar to what we saw with PowerShell. In this case, I'm going to use DHCP. Static requests a little bit more information, DNS, gateway, etc. But by flipping the DHCP button, all I need to provide is similar to what we saw with PowerShell, is a range within outside of my DHCP scope that's going to essentially provide the IPs for the load balancers and services. We provide some information about our subscription that we're going to use to integrate with Azure, no costs associated with that component. Review our settings, and then we click create and essentially finish that first part of the process. And that's when the deployment is going to kick off. So it's going to download the images, it's going to start initially installing the relevant modules and components, and then it's going to deploy that VM that we saw in the PowerShell example onto our Hyper-V host that we've got here. And that download is actually going to include both the Linux Mariner OS from Microsoft and the Windows Container Host image. So a slight difference, at least in this release, compared with the PowerShell approach, which only downloaded the Linux image. So you might find that the Windows Admin Center based approach does take a little bit longer because of that. It's a slightly larger file to download, but we orchestrate that whole process. So it's pulling down the files, waiting for that, and as you see, we fast forward a little bit. It took around 25 minutes in this case, but everything was downloaded successfully. We've created and configured and installed the necessary components on the system, on the host, and also deployed that management cluster VM in essence, which we can take a look at now. So that's the process completed. Everything's up and running. We've no target clusters at this stage, but you can see that the actual platform services management cluster has provided us some information there. And we'll move on to deploying a target cluster later. But let's have a look at the VMs. You'll see, same as PowerShell, this PowerShell approach from before, a single VM deployed, a slightly different name based on what you called it during the deployment there. But that, in essence, is the Windows Admin Center equivalent approach to deploying the platform services for AKS-HCI. So back to the architecture. We've got our management cluster or platform services deployed, and now it's a case of deploying the target cluster to run our applications and workloads. So let's take a look at that. Okay, so we're back in the environment where we finished previously deploying the platform services, and in this case we're going to carry on deploying now the target clusters to run our applications and workloads. So what we've got on the screen again to refresh is we've got Hyper-V Manager on the left where we'll see VMs pop up as we deploy certain commands and certain workloads get deployed as part of that. And then on the right we've got our ISE, PowerShell ISE, where we're going to run some of those commands from. So the first thing we're going to do is we're going to check what Kubernetes versions are available for us to use for our deployment of our target clusters. And you'll see that across Linux and Windows worker nodes, we've got a variety of different versions that we can utilize. So the next stage is to simply define a new AKS HCI cluster. Give it a name, how many control plane nodes we want, how many Linux nodes, how many Windows nodes. And you'll see as part of the deployment, we've accelerated this pretty aggressively here for the demonstration. But you'll see the different VMs are getting deployed, the control plane, the load balancer. Those are both based on the Mariner OS, the Linux OS from Microsoft. And then additionally, we're going to deploy the worker node, which is the first Linux worker node that will actually run our applications and workloads in the environment. So again, we've accelerated things here. It doesn't typically go quite as fast as that. But within a few moments, a few minutes at most, you've then got a working worker node ready to accept your applications and workloads. So let's take a quick look at the cluster information there by running get AKS HCI cluster. You'll see same version, one Linux worker, one control plane. Now, if we want to scale this up to add additional worker nodes, either additional Linux worker nodes or additional Windows nodes, we can run this set command, which is essentially going to, in this case, increase our Linux worker node count from 1 to 2, and it's going to add the Windows node from 0 to 1. Now, in this case, because we don't have the Windows node already downloaded, the Windows container host image already downloaded, we're actually going to go ahead and do that, which will take a little bit longer initially, and then it's going to extract and start deploying the actual nodes. So you'll see now on the left-hand side, the workers are starting to be created, the Linux and the Windows nodes, and within just a few moments, we'll have completed that part of the process. So that the main part of that process is that initial download of the Windows container host image, which once that's done, it'll be reused for future deployments, so you won't have to repeat the process again. Now, getting the cluster information again, you'll see 2 workers for Linux, 1 Windows worker, all part of the same cluster object, so we can manage that efficiently, ensure efficient utilization. And then if we want the kubeconfig information for this particular cluster, we go ahead and run the get AKS HCI credential command. And you'll see there the config file is something we could then use with kubecontrol or alternative tooling. So that's our PowerShell approach, but what about our Windows Admin Center approach for the same thing, it's the same deployment of a cluster? So we come into Admin Center, we click on Basics here, and we provide some information. We can optionally integrate with Azure right off the bat for Azure Arc Management, which we'll explore a bit later on. In this case, I'm going to define my subscription, create a resource group. So you'll see I'm going to create a new resource group in a specific region. And click OK. And then from there, we define the name and information associated with this particular target cluster. So I'm going to give this a name of AKS HCI Clus 001. It's already got the host loaded. We'll provide a password for authenticating against that particular host that's running the platform services. And it will bring back the version that we can utilize. We can drop down and change that for this cluster if we want. We can specify sizes of our node pools, primary node pools, and then additionally define our worker node pools. In this case, I'm just going to give it a name of Linux pool for our Linux workloads. It's just one node. I can change the size as well. And I can also add additional worker nodes from Windows in a Windows pool as part of the same cluster as we saw earlier with PowerShell. I'm just going to keep things simple for now with my Linux pool. We can integrate with Active Directory, which is again a powerful feature for enterprises especially. From a networking standpoint, I've got some configuration options. We'll be adding more as we go forward throughout the preview process. But right now I'm going to leave things as basic configuration and my proxy as is with the HA proxy. And then finally, where's my persistent storage? Well, I'm going to use the V drive we defined earlier. This is going to use that that persistent storage to store and integrate with our workloads. And then we're creating the cluster. So you'll see within a few clicks and a few minutes, that deployment is now completed and we have our target cluster for running our workloads. And if we go back now, you'll see in this view, we've got our Kubernetes cluster. I can download the kubeconfig file, similar to what we saw by using the PowerShell commandlets earlier. And I can take a look at that kubeconfig file in YAML format, and you'll see it just gives us information about the cluster, some secure credentials, some client and key certificate information. And now it's time to deploy an application or a workload. So how do we go ahead with that? Well, when we think about deploying an application or workload, the first thing to be aware of is when you're deploying into this environment, we're going to use something called a manifest file, essentially a way of describing the building blocks of an application that's going to be run within containers. Now I've got a simple example of one that I'm going to share with you just briefly here, and it's an Azure voting application that we've written. Now if I make this a little bit bigger so it's a bit easier to see, you'll see that this particular application is made up of a backend that's actually running Redis. And then if we scroll down, we can see the kind of metrics and performance requirements it has and ports. And you can see also then there's the front end of this application, where in this case it's going to pull an image from the Microsoft Container Registry for this specific application. And again, some resource requirements and metrics there, and also some information about the load balancer as well. So all of that is contained within this YAML file that then we use as part of our deployment. So if I open up our PowerShell ISE, what you'll see here is if I bring up my pre-built script that I'm going to run to make things a little bit quicker. Firstly, we'll get the credentials for our cluster that we deployed earlier. Doesn't matter whether I deployed it with Admin Center or PowerShell, same result. We're going to use kubectl to get our nodes, and you'll see we've got a few listed there. Now, I'm going to use this command to actually apply this configuration from GitHub, but I could have used the local file as well. And then that's going to essentially instantiate the new services in the environment and start the deployment off. You'll see that if I run this get service command, specifying the azure-vote-front as the argument there, that's going to return that actually we've already established the service now. It was really quick, and you're going to access that through the external IP that you'll see listed here. So that's actually something that our load balancer has allocated from our ranges that we defined earlier. Now if we access that particular IP address, you'll see we've got our voting app, and that's running in a container on AKS HCI, all powered on this single Azure VM environment that we're using for eval. Now if I run get pods, and you'll see it's going to return the different pods that have been deployed as part of that application. Now if you remember back in the YAML file, I know it was pretty quick, but in that YAML file it just specified a single essentially replica for each of the key building blocks of this application, the back end and the front end. If I need to scale that out, then I can run the scale command with kubectl. In this case, I'm specifying replicas 5 for the front end, and you'll see if I watch that, that's going to start deploying. In this case, they're already running because it's so rapid to spin up new containers. So there's now 5 front ends running for the application and 1 back end. So what we've looked at there in AKS HCI in pretty quick speed is essentially how we deploy target clusters with both PowerShell and the Windows Admin Center. We've retrieved credentials, we've explored a YAML file, and then we've actually used that YAML file to deploy a simple voting application across a couple of containers within AKS HCI. So easy stuff, but hopefully not too daunting if you're new to Kubernetes. Now I mentioned earlier that AKS HCI is hybrid by design, but what does that actually mean? Well, firstly, AKS HCI natively integrates with a number of Azure-based technologies such as Arc, Monitor, and more. And with it being an Azure service, you pay for what you use. With it being consistent with Azure and Kubernetes in general, it means you can easily move your workloads between environments and at the same time benefit from a consistent user and developer experience. But what is Azure Arc? For those of you not familiar, Arc provides a number of benefits and capabilities. Firstly, it provides a powerful centralized way to organize, manage, and govern resources at scale with powerful scripting tools, the Azure portal, and APIs. You can then bring modern cloud-native development techniques anywhere to build iteratively on your choice of any certified Kubernetes distribution, of which AKS on Azure Stack HCI is one. And on top of all of that, you can run Azure Data Services on premises, at the edge, and in multi-cloud environments using Kubernetes on the infrastructure of your choice. And this could be Azure SQL Managed Instance or Azure PostgreSQL Hyperscale delivered to your chosen Kubernetes environment, orchestrated through Azure Arc. Now, with AKS HCI, there are 2 ways to optionally integrate with Arc. The first, you would have seen when deploying a target cluster with Windows Admin Center earlier. And you saw how easy it is to enable that Arc integration during deployment. Now, the second approach is to use PowerShell, and this can be performed after the deployment of the target cluster is complete. So as you can see here, all you need to do is install Azure CLI, register the Azure Arc enabled Kubernetes in your chosen subscription, create a resource group and a service principal, and then run the PowerShell commands to complete the onboarding. But what does it look like once you've onboarded? Well, let's take a look. So here we are in the Azure portal, specifically looking at our Kubernetes target cluster that we integrated with Azure Arc as part of the deployment process earlier when using Windows Admin Center. And so what we have is now an object in Azure that's enabled through the Arc for Kubernetes service that we're building within the broader Azure Arc that enables us now to apply specific controls, configurations, integrations to our Kubernetes cluster, even though it doesn't reside natively in Azure. So if we explore some of those briefly, you can see on the screen here we've got GitOps, we've got Azure Policy, we'll explore those shortly. But on the left-hand menu here, we can start to integrate with monitoring for our applications and clusters. We can integrate with different configuration items like GitOps and policies, as we mentioned. Now that it's an Azure object, we can do so many different Azure-related tasks against this particular cluster. Now, if we look at an environment that's a bit more fully featured, you'll see in this case, same kind of view. We've got our Arc for Kubernetes list of clusters that we've integrated with the service here across different clouds. We've got native Azure Kubernetes service clusters running in Azure as well. But going back to the Arc for Kubernetes, you'll see we can view the different versions of these clusters, where they've been integrated in terms of the resource group location. And if we drill into one in particular, this one running EKS, you'll see that same kind of thing as we saw before, but here I can do things like enable GitOps integration. And here's a configuration that's actually already been applied to this particular cluster. And it could have actually been applied to all of our clusters in the list that we saw earlier, including our cluster that we deployed as part of the demo earlier. And what this cluster config file essentially is, and you can apply more than one, is a way for us to standardize what gets deployed out to a particular cluster within our environment under our control. And you'll see in this case, the GitOps integration and controls are enabling us to pull essentially application files, code, builds from a specific repo. In this case, it's on GitHub, but it could be another enterprise Git equivalent, and bring that and deploy it down to our Kubernetes clusters in an automated fashion using the GitOps technologies powered within Azure Arc for Kubernetes. Now, in addition to GitOps, if we go back to our policies view, here you'll see that we can actually start to apply governance against our Kubernetes clusters in the same way we can against VMs and other resources within Azure. So this might be specific Kubernetes settings you want enabled, password policies, certificates, and more. So Azure Policy is an extremely powerful way for you to, again, help standardize the different Kubernetes clusters that you're deploying within your environment, no matter where they are, in Azure, on premises, on AKS HCI, across different Kubernetes offerings on-prem and in alternative clouds. So that's the power that Arc for Kubernetes really brings on top of your Kubernetes environments that you've got deployed. So we've seen how easy it is to deploy a simple app into a Kubernetes target cluster on AKS HCI. But the beauty of AKS HCI is that it's not just limited to Linux container hosts. AKS HCI provides leading support for running Windows containers side by side with Linux applications all in one place. No need for separate clusters for separate workloads, which leads to a better utilization of underlying resources. Also, all of the support is centralized and streamlined. Finally, we've made significant investments in security. AKS HCI has been built with security ingrained. We harden the container host images, both Linux running on Marinette OS and Windows, and we continue to provide updated images as we go forward, maintaining stringent security standards. We've also enabled integration with Active Directory and have an inbuilt zero-touch CA to handle cert enrollment and renewal. And finally, AKS HCI, like all Microsoft products, is engineered with security as a core principle. And on top, easily integrates with solutions like the Azure Security Center for threat monitoring, detection, assessments, and more. But when would you use AKS HCI? Well, as we've said, it's great for containerizing both Linux and Windows apps on-prem. Think about legacy .NET applications in your environment. These could be containerized and run on AKS HCI. It's also a great platform for developing new applications built with the cloud in mind. And through our integration with Azure Arc, you can bring powerful Azure services down to run on AKS HCI. One example of this being the Arc-enabled data services, enabling you to run services like Azure SQL Managed Instance on-prem in your environment. So to wrap up, let's reiterate that bottom to top architecture. Starting at the bottom, you've got that validated enterprise class hardware with Azure Stack HCI 20H2 running on top, providing the scalable, high performance platform for traditional VMs that can be managed on-prem with Windows Admin Center or from Azure with Arc. You then deploy AKS HCI on top and provide a platform for running your containerized Windows and Linux workloads. one layer higher and you've got the Azure services deployed down onto Kubernetes, such as the Arc-enabled data services, all managed from Azure. Top to bottom, this is a powerful, scalable, resilient solution for traditional and modern applications and workloads with one place to go for support. So how to get started? Well, download the preview, try it out. The links will be on the next slide, but I can assure you getting started with AKS on Azure Stack HCI is quick and easy. And we have options for those of you who don't have any spare hardware by testing in Azure. There's also a fantastic Azure Arc Jumpstart site where you can continue your learning around Arc for Kubernetes and more, and again, the links will be on the next slide. So here's a list of valuable resources. There's links here to download the preview bits, guidance on running in Azure for evaluation, the Azure Arc Jumpstart, and more. And with that concludes the session. Thanks for watching and good luck with your evaluation of AKS HCI.